Hello. Please excuse me, my voice is kind of rough. Caught a cold over the holiday, but I'd like to share a little bit of information about relays. What are they? Do you need to know anything about them? What do you need to know about them? I'm going to try to answer a few of these questions in this tutorial. So, starting off with, this is one of your more common little old 5-pin square. Used to be common, not near as common now. This 4-pin, and you can see right here, been clipped. It's actually a 5-pin. That's what it originally looked like before the manufacturer cut this middle pin. This is a 4-pin, and this is just a simple on-off switch. Real simple. Now, this is pin 30, which is what most people seem to think should have power going into it. This is a misconception and not true. All you need is a wire connected here, either to send power, ground, or to receive power or ground. All it's doing is making a connection with one of these two pins here. Pin 87A is normally closed with pin 30. That means these two are connected when there's no power here and here. When you supply power to pin 86 and 85, it breaks connection to pin 87A, and then pin 30 is then connected to pin 87. So, basically all this is, it's an electromechanical switch. What does that mean? Well, it takes an electrical signal on pins 85 and 86, and usually these are interchangeable. You have ground coming in here, power coming in here, or vice versa. Doesn't matter most of the time. Once in a great while, you may find one that does have a resistor or a diode in it. If that's the case, usually the color will be different. But on the black ones, all you need to know is power and ground on this. You energize the circuit. Now, basically like this little 4-pin, you're making connection. That's all it is. On these 5 pins, what it means, once you've supplied power and ground to 85 and 86, you've broken connection between 30 and 87A and made connection between 30 and 87. Now that means that you can turn something off or turn something on at the same time. Now, I have here a couple of little mock-ups. Thought might be interesting to show you. This is just a simple 5-pin connector, or 5-pin relay, just like this little nugget. Same thing. And this is an LED flasher. Now, why an LED flasher? Because you need something with very low input or resistance. So, anyway, we're gonna hook this up. This is a ground wire. These are 2 lights. Now, got a little battery pack right here. I'm gonna hook up my ground. I've already got my power here, all the connections made. Now, when I apply power, what I've got is power going into my flasher, a ground from my flasher because it's LED. LEDs use very low current, so they will continue to flash at pretty much anything. Power between the two. This thing is then supplying power over to the pin 30. Pin 87 and 87A are connected to these. Now, when I turn this on, you can see they're flashing back and forth. And essentially, I'm making and breaking connection because this thing is turning the power on and off to pin 86 on this. Could I do it with the power going to 85 and ground on pin 86? Yeah, same thing. Don't matter which is where. Just the main thing is, here's a good visual reference to one of the things you can do with a relay. Now, turn that off. Take these off. Now, these are just my simple power connections to my battery pack. I'm going to lay this over here for right now. Over here, we have a nice 12-volt battery, but I've also got a 20-volt tool battery. What's the deal? Well, this is just so I can show you you don't have to have a 12-volt system connected to one of these relays. As you can see here, and you may not be able to see it very well, but this is a positive lead. This is a negative lead. The negative lead I have coming over here to this motor. The positive lead I have coming in here on pin 30. Pin 87 I have going to the other lead on this motor. Now, this is a very small little micro switch, something that you would use to turn on an LED light or something very small. There is no way this switch is capable of carrying the current that this motor needs to operate. However, because I have this hooked up to supply the signal power to my relay, it turns the motor on, runs it just fine, because all this is doing is sending signal power to my relay. The relay is then supplying the actual voltage and amperage to my motor. Had I tried to hook this between the battery and the motor, it would have smoked this switch. Wouldn't have taken any time at all. Now, I can disconnect my little battery pack and hook up this 12-volt motor here. Will the 20-volt motor actually work on a 12-volt battery? It's designed for 20. Let's try. Spinning good. Only thing is now you're underpowering this. So it's not got the same RPMs. It won't do the same amount of work as what it will do off this 20-volt lithium power. So basically, a relay, all it really is a small switch capable of carrying a big load. Also, it's capable of turning off one circuit and on another circuit. As long as you have 5 pins, you have normally open and a normally closed circuit. Now, what happens if you can't read these numbers? Maybe they've gotten destroyed or something. Maybe your eyes just ain't good enough to see it. Well, get you a little old multimeter. And this could be a fairly decent one. It could be a super cheapy Harbor Freight job, like this one here. These are fine. You could even have an old antique Sun Pro, like I have here. This thing has been faithful. I've used it for a lot of years. It still works fine. But we're going to go ahead and use this one. So, you need to know what goes where. Turn this thing to your resistance setting, and again, on your multimeter, yours might have auto ranging. This one doesn't. I'm putting it on the 200 ohm setting. Now, just select any pin, doesn't matter which one, and then start going to the other ones. Okay, right there. I have 101.5 ohms. That tells me that that is my signal wires. So this one and this one, these two here, on this one, are my coil wires. Those are my signal, power and ground. Now, let's test some of these others. All right, what about that? These two right here go to 0 ohms. So this is my normally closed. These would be my normally open. Simple, easy way of finding out what works where. Now, what is inside a relay? What's so mystical? What's so magical? A lot of people get confused. Well, just so happens I have a nice little square 5-pin relay that I have removed the casing on. All you have here, as you can see, is a coil of wire and a little set of contacts. You can see that this piece makes contact with this. But if you energize it, it moves over, so this piece now makes connection with this. So basically, this right here is your pin 30. This is 87A, this is 87. That's all there is in here. Now, let me get this, and I will show you what I'm talking about here. 87 and 87A. Now, hopefully you can see this. I'm fixing to turn the power on, off, on, off. You can see the contacts making and breaking connection. And like I said, all that this little bitty tiny switch is doing is energizing this electromagnet. That's all there is here. You can actually take the electromagnet out as long as you can make connection. Now this one was broken, but I scraped this wire, and the reason this thing doesn't short out, this has a small coating on these wires. They look copper, but they have a coating to keep them from making contact. Now, make connection here and here. Well, if I can get this on. Now, turn my power on. See how that comes in there? Whoop. You can easily push those too far. Now I've got it far enough out, it's not wanting to come in and close on it. But if I take a little screwdriver and put in here, it doesn't try to stick or hang or anything. Put power to it. See how it connects? And it doesn't want to let go. It's on there. Release the power, and she drops. These are just simple little electromagnets. They're a coil of wire wrapped around a metal center. And whenever you energize this circuit, and basically this circuit, all it is, it's a dead short. But you have a magnetic field running through this wire, which energizes that metal rod. And you can see right there, she's held nice and tight. As soon as I disengage, pop, there it is, it's open. So basically, there's nothing mystical, there's nothing magical about relays. They're very simple. Are these the only kind of relays there are? No. How about a blast from the past? This is a really old one. Probably dates from the 80s. Got a metal outer skin, tabs that you'd have to bend out to get into the coil and the points. This is what we used to use way back when. They keep getting smaller and smaller and more efficient. You also have some of these. They're for more electronics. Also, we have basically the same thing as these others, but they're actually designed to fit into a circuit board. So you can actually have holes in your circuit board, solder these in place, and again, we're using electronics. You can energize and de-energize your 87 and, or excuse me, your 85 and 86, connecting 30 and 87 together, thus creating a connection and allowing a higher current to flow. It could even be a different voltage. Now, on most of these, I don't know if you can see that very well or not, but this tells you what the voltage rating is and what the amperage is. So this one actually takes, the coil is 12 volts DC. The points themselves can carry up to 70 amps at 14 volts. Now, as I showed you earlier, the points can handle a lot more voltage than that. 90% of them can. Now, some of these smaller ones, they may not carry quite as big a load. This one I'm not seeing on it, but you can put in these numbers, search the internet, find out what this is capable of carrying. It probably won't be near as much as this one will. This is just bigger and stronger. Now, if you have an old relay and it's not working right, probably, as long as it's moving back and forth, the contacts, all it is your points are worn. Take a nail file or an emery board, get in here, clean these up some, your relay will start working again. That's all it is, just a bad set of points. They're not making connection. Clean them up, they'll start working. And what kind of switches can you use to operate these? Anything you want. A rocker switch, momentary push buttons of different sizes, they'll all operate them. Like I said, all you got to do is send either power or ground momentarily to either your pin 86 or your pin 85 to complete the circuit, as long as you have the other on the opposite pin. So as long as you've got a ground on 86, you send power to 85. Now she's just energized, and the 87 and 30 will be connected, sending power or ground to whatever you want. Now hopefully here in a bit I'll be able to make another video and I will show you how to take a little 12-volt motor in reverse directions using 2 of these 5-pin relays. I don't know how you're going to do that. Basically, in real simple layman's terms, you connect pin 30 of any of these. As long as you have 2 relays, connect pins 30 to both of these. Pin 30 from one here, pin 30 from another here. You supply voltage and ground to 87 and 87A, one on each. And then when you energize your relay, you will be energizing only one relay at a time, which will then finally send power and ground to your little motor. With them not energized, actually what you're doing is you're sending ground to both of these. Ground and ground don't work. You have to have ground and power, or negative and positive. Don't matter what you call it. But if you can somehow, like using relays, turn that one ground into a power, now this thing's going to turn one direction. You take that power away and start supplying ground again, it's not going to do anything. You take your other one and energize it, send power to the other side, and it's going to go in the opposite direction. Been using them for years like that. That's what makes a winch work. So anyway, I showed you how to do a little wig-wag, some of the basics about a relay, and the fact that you can use a 12-volt relay to operate a 20-volt power system. You can use a 12-volt system to operate a 3-volt light if you wanted, or 5-volt, or whatever. So you got a chicken coop and you need lights to come on automatically when you go out first thing in the morning and you got some solar power out there. Hey, relay and a nice little micro switch. As soon as you open that door, boom, lights come on. As soon as you shut it, lights go out. Just that simple. So hope you've learned a little something, and hopefully you can use some of this information to go out and make something, or maybe repair a little something. Anyway, we'll see you next time, and good luck.